Hello and welcome back to Educator.com and welcome back to Biochemistry. So today we're going to continue our review of chemical basics, and we're going to discuss titrations and buffers. So this particular lesson is going to be only a discussion, and I've decided to actually save the example problems for acids, bases, and buffers until the next lesson. And then we'll be done and we'll be ready to jump into biochemistry proper. Okay, let's get started. So we said that a weak acid reacts with water only slightly as follows. So let me write weak acid. So the basic reaction is HA, and A is any species. This is just a generic reaction, plus H2O. And when it does, it's going to come to an equilibrium, H3O plus A minus. So what you're going to have in solution is A minus H3O plus, which is the same as H plus, water, of course, that's in solution, and HA. Now it's a weak acid, so most of it actually doesn't dissociate. Most of the equilibrium is here, which is why the Ka's for these things are actually really, really small. They mean that it doesn't go very far forward, it's mostly this way. So the Ka for this reaction is going to be H3O plus times A minus, which is products over reactants, over the concentration of HA. And of course, we don't include the H2O. Now, very important, this is at equilibrium. This is once the system comes to equilibrium. This is not at the beginning or the end. It's at equilibrium. Okay, let's go ahead and rearrange this equation. So let's rearrange the Ka equation and write it like this. And let me also remind you that H3O plus is equivalent to H plus. It's just another way of writing it. So I'm going to use H plus instead of the H3O plus. So when I rearrange this to solve for the hydronium ion concentration, or the H plus, I move this over here and I move this down here, I get the following. I get the concentration of H plus is equal to Ka, oops, let me start again, excuse me. Okay, let's see what we've got here. So I've got H plus concentration is equal to the Ka times the HA concentration divided by A minus. Now I'm going to end up taking the logarithm, the negative logarithm of both sides. So I've got negative log of H plus equals negative log of Ka plus the negative log of HA over A minus. Now here what I did is Ka something times something. When I take the logarithm of A times B, it's the logarithm of A plus the logarithm of B. So that's all I did. I just used the property of logarithms. Well, the negative logarithm is the definition of pH. So this becomes pH equals pKa minus the log of HA over A minus. In other words, the acid form over the conjugate base form. Well, generally, you can leave it like this, but generally we don't. We tend to prefer plus signs. So if I flip this, if I take the reciprocal of this, I can actually change this to a plus. So I end up with the following equation. The pH equals the pKa plus the log of the concentration of conjugate base, A minus, that thing, okay, let me go back to black, over the concentration of the actual acid itself, that thing. Now let me go back to black. This is called the Henderson-Hasselbalch Equation. Henderson-Hasselbalch Equation. Very, very important equation, probably the single most important one regarding acids, bases, and buffers. We're actually going to be talking about this in a minute once I start talking about buffers, but I'm going to do titration first. But I did want to introduce it to you, and this is the equation that you're going to definitely use, particularly when we do our example problems. Now, let's just talk about what this says. This says that in a weak acid solution, if I ever want to know the pH of that solution, and if I happen to know the pK, the relationship between the pH, the pKa, and the concentration of acid and conjugate base is expressed this way. I have one thing, hydrogen ion concentration, I have the Ka, I have the conjugate base concentration, and I have the acid concentration. There are 4 different parameters here. If I have any 3 of them, I can find the 4th. That's what this equation is. It's a relationship between these things. Hydrogen ion concentration, Ka, acid concentration, conjugate base concentration. Very important equation. Okay, and again, we'll return to this in a little bit when we talk about buffers properly. Okay, so let me introduce what I call the fundamental reaction of acids and bases, which you already know. You know that if you take an acid plus a base, you get a salt plus water, neutralization reaction. I tend to call it the fundamental reaction of acids and bases. And we'll use this as a beginning to discuss our titration, because that's what a titration is. Okay, anytime you put an acid together with a base, essentially what you're doing is you're putting an H plus near an OH. Anytime an H plus and an OH minus are near each other, they're going to form water. This is the fundamental reaction. This will always happen. Okay, this is the idea behind a titration.